Welcome back, everyone. In this lecture, we're going to be focusing on two built-in modules which relate to opening and reading files and folders on your computer. And that is the Shell Utilities module and the OS module, so Shuttle or OS. Essentially, we already know how to open an individual file with Python. We saw that at the very beginning of the course. But we still don't know how to do a few things, such as, what if we have to open every file in a directory and read and write to it? How would we actually find those correct directories and loop through them, especially if there were subfolders within subfolders? Also, what if we actually wanted to move files around on our own computer? Python's OS module and Shell Utilities module allow us to easily navigate files and directories on the computer, and then perform actions on them, such as moving them or deleting them. Let's go ahead and explore these modules and get started. Okay, here I am underneath Advanced Python Modules folder. I wanted to note here that the lecture notebook that corresponds with what we will be showing here is called Opening and Reading Files Folders. So keep in mind it's not called something like OS module and Shell Utilities. So right now the lecture notebook is this one, Opening and Reading Files and Folders. And I would recommend that you follow along with a notebook in the same location as me, which is under Advanced Python Modules, since we're going to be doing things like listing directory structure, and if you want to see similar results, it should be in the same location as where I am. So I've gone ahead and created a new untitled notebook, which is this right here. All right, so again, if you're doing this in another directory on your computer, keep in mind the results you see may be slightly different than ours, but the actual logic should still be the same. To discuss opening and reading files, let's quickly review an understanding of file paths. If you're in Jupyter, you can type pwd, hit enter or shift enter, run this cell, and it will report back your current working directory, which is right now here under Complete Python 3 Bootcamp and then Advanced Python Modules. The second most important thing to note here is it actually reports back the syntax structure for writing a file path for whatever your operating system happens to be. In my case, I'm using Windows, so it separates folders or directories with this double backslash. And that sort of formatting is important later on, so keep that in mind. If you're using something like Linux or Mac OS, it's probably going to show you a /, but it should show you the correct format. Okay, so I understand now where my notebook is located. What I want to do before we get started is create a practice file. So I actually already know how to create a practice file or any text file, write to it, and close it. Now what I mean by that is early on in the course, we covered doing something like this, where I will open up practice.txt file, and since this actually doesn't exist yet, it will actually be creating a text file, and I want to write to it. So I will have my mode be write plus, and let's go ahead and write something to this. This is a test string, and then I will close the file. You can do this with a with statement if you prefer. So if you run this, basically what happens is it's going to open up practice.txt file and overwrite this is a test string on it and close it off. So now if I take a look at Advanced Python Modules, you should be able to scroll somewhere here and see practice.txt file, which if you click on it and open it, it says this is a test string. Perfect. Okay, so we'll be working with that text file later on. But let's come back to our notebook and first discuss how to use the OS module. So the OS module is really useful because it allows you to do things like get the current working directory or list all the files in a directory, and these commands work across all operating systems. So I simply say import OS, and I can say os.get cwd current working directory, open and close parentheses, and it reports back the current working directory. So pwd right here, this is kind of a special command within Jupyter. It also works technically at your command line if you're running something on Mac OS or a Linux-based system. But this os.getcwd, that will work within any Python script. It'll report back your current working directory. And let's imagine I wanted to list items in a directory. If I say os.list_dir, it will list everything in my current directory. So here I can see all the notebooks I had, I can see some folders, the text file, as well as the practice.txt file, and my current notebook. Now by default, if you just say list dir, it's going to list all the items in the current working directory. What I could do is list items in another directory. So for example, if I wanted to, for instance, figure out what are all the files and folders I have under users, I can run that, and now it's going to list everything underneath users. So I can see all users, default, my profile, public, etc. So list directory essentially just takes the argument of path, you pass it in, and it lists all the items there. This will be very useful if you wanted to maybe have a for loop to open up all the files in a directory. And we'll see later on how we can do that in an even more robust manner through os.walk. So now we know how to get the current working directory, and again this works on any operating system or any Python script, and we know how to list all the items in any directory. Now let's go ahead and show you how you can move files around, which is something we actually don't know how to do yet. What I'm going to do is I'm going to import the shell utilities module, which is just shutil, and it can be used to move files in different directions, or in different locations I should say. So right now I have my practice.txt file located right here under Advanced Python Modules. Let's go ahead and show you how you can move it. You simply call shell utilities.move, and it essentially just takes two main parameters, which is src, the source, and dst, the destination. So it's very similar to the Unix mv command. If you're comfortable with the Linux command line, this should feel familiar. Essentially what we're saying is take this source and move it to this destination. So let's go ahead and grab that practice.txt file, and then the next thing I need to do is tell Python where I want to move this file to. I need to choose somewhere where I actually have permission to move it to. So if you're running this on a work computer or work network where you don't have full admin permissions, you may actually encounter an error here. So make sure you have permissions on your computer to do this. I know that I'll have permissions in my own user folder, so let's go ahead and do that. Going to copy and paste this path. Let's type that in, move that, and now basically it reports back that this practice.txt file is now located underneath my username. And if I take a look back at my folder, Advanced Python Modules, and scroll down, notice that practice text file is no longer there. And if I were to search on my computer underneath my username, I would find that practice.txt file there. And I can actually confirm this by just saying os.listDirectory. Let's go ahead and list everything that's under my username. Whoops. Run that. And I should somewhere here be able to see that practice.txt file. So if you keep scrolling down, eventually, let's make sure it's in alphabetical order. Here it is, practice.txt file. Perfect. So I was able to take a file and programmatically move it somewhere else on my computer. Now something to keep in mind is OS has a lot of functionality available on it. So as you get more advanced, you may find yourself wanting to do more things with it. You can say os.tab, and you'll notice that it has a huge list of things it can do. For the most part, we're just going to be teaching you the basics here, how to move things around, how to open things, list directories, and how to remove things. So there's three ways to actually delete a file, and I talk about this within the lecture notebook, so I'm just going to quickly bring that over to discuss it. So I'm going to scroll back up here, and here's the deleting file section. So we just went over moving things. And deleting files, you should note that the OS module provides three methods for deleting files. There's os.unlink_path, which is going to delete a file at the path you provide. There's os.rmdir, which deletes an entire folder, however the folder must be empty at the path you provide. So unlink is for a single file, remove directory is to remove a folder. Folder has to be empty first, so essentially you have to unlink everything within that folder, then remove the directory. And then there's the shell utility command, which is remove tree. And this is probably the most dangerous one, which is the one I really want to talk about here. This will remove all files and folders contained in the path. This one you have to be super careful with because these methods can't actually be reversed. So they're operating essentially at the command line, which means it's not like just clicking something and dragging it to the trash, and if you made a mistake, you can take it out of the trash again. Once you delete something using remove tree, it becomes extremely difficult to try to recover the file. And you should just assume that you're not going to be able to recover it and it's a permanent removal. So keep that in mind. You should really be careful with this remove tree command and only use it when you're absolutely sure that you would have no problem deleting it, especially if there's a possibility this path could change. So because this is such a dangerous method, what I suggest you use if you find yourself needing to remove files is the send to trash module, which is actually an outside module you need to download. So you need to pip install send to trash at your command line. So open up your command line and type pip install send to trash, and then you should be able to import it. So send to trash is safer because it will send things to the trash bin instead of a more permanent removal. Okay, so again, OS module, it can delete files, delete empty folders, or delete everything within a folder, including all the files in it, but it's pretty dangerous to work with because it's a permanent removal instead of moving things to the trash bin, which is why I recommend, if you do find yourself doing this, check out send to trash first. So let's explore send to trash. I'm going to come back here, and what I want to do is, after you've done installing it, import send to trash. There we go. And let's check everything that's in my directory. And I currently don't have that practice file in my directory, so let's go ahead and get it back. What I'm going to do is say shell utilities, grab the practice.txt file, which is currently located under my username, and then I have to figure out where I want to move it to, and I will move it to my current working directory, which I can simply say os.get current working directory. So that says grab that practice.txt file and move it back here. So I run that, it reports back now its location, and if I try to list these directories again, I now see practice.txt file has been moved back to my current location. Let's go ahead and send this to the trash. It's actually quite easy to do. You simply say send to trash dot send to trash, and then you just provide the full file path or file of what you want to send to the trash. So I will send this practice.txt file to the trash, run that. It's now in my trash bin. It hasn't been completely removed. I could recover it if I really needed to. And say os.list directory, and now I no longer see that practice.txt file. And now the last thing I want to show you in this lecture, which is probably the most useful, at least in my opinion, functionality of the OS module, is os.walk. And if you type os.walk and do Shift Tab here, it essentially takes in one parameter, top, and it says it's a directory tree generator, which essentially what that means is for each directory in the directory tree rooted at the top, it's going to yield a tuple. The directory path, the directory names, and then the file names. So the way I like to think about this is by creating a for loop. So we'll say for folder, comma, subfolders, comma, files. This is tuple unpacking in os.walk. And if you want, you can pass in your current working directory. But the reason I recommended you follow along in the same location we did is because I'm going to take a look at, if you go to Advanced Python Modules, up here, I created an example top-level folder. If you click on example top-level folder, notice there's two folders within it, midexample1, midexample2, and there's an actual file within the middle, midexample.txt. If you then go to midexample1, notice there's two bottom-level folders, some mid-level document in here, and then there's one text, etc. Bottom level 2, there's bottom text 2, come back up levels, go to midexample 2, and this one is empty. So what I want to do is actually pass in the file path for this example top level, and this should give you a good idea as well as a simple comparison to be able to understand how os.walk is reporting back results. So I'm going to come back here, and I'm going to say the following. I'm going to say os.walk, and let's go ahead and actually grab the directory for this example top level file. And the way to do that is, let me insert a cell above this and quickly grab our current working directory. So I'm going to grab this guy here, paste it in, and in fact let's do this on 2 lines so it's a little easier to read. So we'll say file path is equal to, and then we have this kind of long file path here, users, etc. And I'm not just going to look at Advanced Python Modules, I'm going to say // example underscore top underscore level. Note my capitalization here. Okay, and let's actually put this in a separate cell. So there's my file path. I'm going to look directly at example top level. So we'll say for folder, subfolders, files, and os.walk for this particular file path. If you want, if you're operating on a different computer, and for instance, you don't have access to our specific advanced Python modules, you can replace this with os.get current working directory in order to explore what we're talking about here. But to get the same results I do, go ahead and check out this example top level folder. And then inside of this, we'll add in a couple print statements so we can clearly see what's going on. I'm going to print using, let's say, fstring literals here, currently looking at, and then I'm going to report back the folder I'm currently looking at. I'll print a new line with \n, and then I will print the subfolders, or really subdirectories, are, and now let's report back for every subfolder. We'll say for every subfold in subfolders, print, and what we're going to do here is again fstring literal, subfolder, and then what I'll do here is paste in that subfold. So it's going to report back the folder, and then I'm going to go through each subfolder or subdirectory within this, and then I'm going to print a new line. I'll do the same thing for the files. We'll say print the files are, and for f in files, I'll say print fstring literal here, file. Let's type in that f there to print out the file name. And once this is done, I'll print out a new line. And just for more organization, what you could do if you want, you can add in tab spaces. So essentially \t is a tab. So we can do that within these. So it says currently looking at folder, it'll list the subfolders indented, and it'll list the files indented. Let's go ahead and run this, make sure we didn't commit any typos. Looks like I have one minor typo. I accidentally said subfolders instead of sub_folders. Let's fix that. And there we go. Okay, so what is this actually looking at? It reports back, I'm currently looking at this folder, example top level. Recall, that's what I have here, example top level. So we're going to kind of do this comparison. It reports back the subfolders, mid-example1, mid-example2. So if I take a look here, I see mid-example1, mid-example2. Note these are folder directories. It's not just a single file. It says the files underneath this are file mid-example.txt. Now what OS walk is going to continue to do, it's then going to open each of these subfolders and report back, hey, now I'm looking at mid-example1. Here are the folders within mid-example1, and here's the file within that. Now I'm going to look at bottom level 1. So now it's looking at this subfolder. It says file 1 text is located in there. Now I'm going to look at the other one, bottom level 2, bottom text 2 is located there. Then we're going to go back up and now view mid-example 2. There were no subfolders there and there were no files there. So if you recall, mid-example 2 was just empty. So we can see here that OS walk, what it's going to do is essentially make a tree, and it's going to look at every single thing inside of this file path location. It's going to look at the folder, it's going to look at the subdirectories or subfolders, and then it's going to look at the files. And hopefully what you can do then is add in logic. So maybe you're looking for every text file within a certain directory that starts with the year 2010 or 2020 or something like that. Well, you could use this and then have some sort of if statement to check the file names. And now you can very quickly and programmatically look within directories within directories. So OS walk is extremely useful. It takes a little bit of time to get used to this sort of kind of tuple unpacking, as well as the way the tree directory actually works. But hopefully this example kind of allows you to have a relationship between what is reported back versus what is actually there. So I would highly recommend you run this on the file we created, example top level, in order for you to make the direct comparison to understand how it's looking at files, subdirectories, and the actual raw files. Okay, if you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture.